Hi students, this is Mr. Yao. Today we are going to continue our learning about solving system equations by elimination. But today's examples will be a bit more complicated than yesterday, so let's quickly review two examples from yesterday's learning. Here they are. For question A, you see there are two numbers, two coefficients that are the same. They're not exactly opposite, but we can easily change one of them to be the opposite. So let's say we want to change this second equation to actually have a -2 right there. We're going to multiply everything by a -1. I'm going to get -5x minus 2y equals -13. And now the first equation and the third equation, they have a positive 2y and a -2y. So I can easily add both equations together. 4x plus -5y is 5x is a -x. Then 2y and a -2y is a 0. 8 plus a -13 is a -5. So we have -x equals -5. We divide both sides by a -1. X equals 5. Afterwards, we can easily put it back into an equation to keep solving for y. So wherever we see x, we're going to replace it with a 5. 4 times 5 plus 2y equals 8. So 20 plus 2y equals 8. 2y equals, subtract both sides by a 20, -12. So y equals a -6. Final answer, 5, -6. That is question A. Moving on, question B. This time you can see we don't have any numbers that are the same, but you should be able to spot that 3 and 12 are very easily related to each other. 4 and 10, sure, they're related to each other, but you kind of need another number to do some extra work to actually change them into the bigger number. Or you can choose to multiply by 2.5, but that's going to get you some decimals that we can easily avoid if we focus on the 3y and the 12y. So 3 and 12, well, 3 times 4 is a 12. However, we don't want another 12. We actually want a -12. Because right now it's a positive 3. I need them to be opposite for them to eliminate with each other. So in that case, I'm going to multiply the top equation by a -4. I have -16x minus 12y, which equals to 6 times -4 is a -24. There you go. Now, I can actually add my second equation and my third equation, because we have a 12y and a -12y. 10x and -16x is -6x. 12y, -12y is a 0. 24 and a -24 is a 0. So we got -6x equals 0. Divide both sides by a -6. Again, 0 is not no solution. 0 is a solution. 0 divided by -6 is a 0. Then we can put it back into an equation. Just keep solving. 4 times 0 plus 3y equals 6. So 0 plus 3y equals 6, which means 3y equals 6, and y equals 2. Final answer, 0, 2. So that's what we learned yesterday. We either multiply an equation by a -1, or we can multiply an equation by just a number or just a negative number. So today is going to get more complicated, where we may actually need to change both equations for them to eliminate with each other. Before we get into it, some little hints. Which variable should we typically eliminate? Well, if we have numbers that are easy for us to make the smallest multiples, so if you say like you have a 2 and a 3 and you have like a 25 and a 70 something, like, well, maybe you should choose the 2 and 3 because they're smaller, easier to deal with. And if two numbers already have the opposite sign, maybe you should actually try to choose that pair, because at least when you multiply to change them, you don't have to multiply by another negative number because they already have the opposite signs. So now let's have a look at a few examples. Example 1, 3x, -15y, and 18. You do have the option to actually multiply by a decimal to actually get to the other equation. That is totally fine. However, if you don't want to do that, you can choose to change them into, say, a number that they share. So for right now, you can either change a -2 to a 3, or you can choose to change -2 and a 3 into something else. I'm actually going to show you when we have to change both equations, since that's kind of the purpose of this lesson. So we have, well, the reason I'm not choosing 10 and -15, well, they're bigger than the -2 and 3, so I'm going to work with the -2 and the 3. First, I can change the top equation, the 3x, into a 6, because 3 and -2, they can both go into 6. So if I can get a 6 and a -6, I can easily eliminate them. I'm going to multiply the top equation by a 2. We get 6x minus 30y, which equals to a 36. Remember, you have to multiply every single thing by the 2. And then for the second equation, well, since I want to get now a negative 6, I'm going to need to multiply that by a 3. Negative 2x times 3 is a negative 6x. 10y times the 3 is a positive 30y. Negative 12 times the 3 is a negative 36. And now, instead of using either of the original equation, I'm going to use both of the new equations. So I can add them together. 6x, negative 6x, 0. Negative 30y, 30y, 0. 36, negative 36. Oh, that's also a 0. So I actually got an equation that is 0 equals 0. Well, does 0 actually equal 0? The answer is yes, 0 does equal 0, which in that case, it means any x or y would actually make this system equation work. So in that case, the final answer is infinitely many solutions. You do actually have to write this whole thing. If you just write an infinity sign, that actually means x is infinity, which in this case is no. X is just any number. That's why we say infinitely many solutions. There you go. That's example 1. Example 2. Negative 2 and 3 opposite signs, 4 and negative 10 opposite sign. But since 4 and 10 are bigger, I might as well just work with negative 2 and 3 again. I can change both of them related to 6. So I'm going to multiply the first equation by a 3. So I got a negative 6x plus 12y equals 51. And then I can multiply the second equation by a 2. So we have 3 and times 2 is a 6x. Negative 10y times the 2 is a negative 20y. Negative 3 times the 2 is a negative 6. Now I can choose to add both of the equations together. And in that case, I'm going to eliminate the negative 6x and the positive 6x. So that's a 0. 12y minus 20y is a minus 8y. 51 minus a 6 is a 45. Wait, is it? Yes, it's a 45. Okay, now negative 8y equals 45, which means my y is a 45 over negative 8. And let's continue. Now we need to actually put it back into either of the equation to keep solving, because we've got y equals 48 over negative 8, or negative 45 over 8. We can actually put it back. Wherever we see y, we are going to replace it with 45 over negative 8. So it's negative 2x plus 4 times 45 over negative 8. That equals to 17. Got negative 2x. 4 times 45 over negative 8 is actually a minus 45 over 2. That equals to 17. Keep going. Negative 2x equals, I'm going to need to add both sides. So it's a 17 plus a 45 over 2 on the right side. That is going to give us a 2 and a 79. Divide both sides by a negative 2. You can type in your calculator for this. So x equals negative 79 over 4. So my final answer is going to be negative 79 over 4, comma, negative 45 over 8. The number seems odd, but we followed everything correctly, so we solved it right. Moving on, example 3. Well, negative 3 and 5, and 8 and negative 5. Well, they're kind of the same value, the similar value. They're not a one pair that's bigger than the other, so you can choose either one. I'm just going to use the first one. Since 3 and 5, I can easily know they can both go into 15. So that means I need to multiply the first equation by a 5 to get to a negative 15. So it's negative 15x plus 40y equals negative 15. And I'm going to multiply the second equation by a 3. So I'm going to get a 15x minus 15y equals 90. Now I can add both equations together. Negative 15x and a positive 15x is going to be a 0. 40y and a negative 15y is going to be a 25y. Negative 15 plus 90 is going to be a 75. And here's the thing. You can totally choose to change the 8 and the negative 5 into a 40 and negative 40. That should also work. So you can always try that as well. Divide both sides by a 25, so y equals 3. And then we are going to put that back into actually either equation. I just have the habit of always putting it back into the top one. So we got negative 3x plus 8 times 3, which equals to negative 3. We'll get negative 3x plus 24 equals a negative 3. Subtract both sides with negative 24, so we got negative 3x equals negative 27. Divide both sides by a negative 3, x equals a positive 9. So final answer, 9, 3. And here's the thing, as soon as you have this answer, here's something you can do to check. You can always put it into the other equation and see if it works. 5 times 9 minus 5 times 3, that's a 45 minus 15. Does it actually equal to 30? It does. There you go. That's a checking process. So for the previous question, example 2, you can actually choose to plug this answer into the second equation. Since we use the first equation to solve it, we can use the second equation to check. So we'll get a 3 times negative 79 over 4, and then minus 10 times negative 45 over 8. And you see, it actually equals to negative 3. That's how you know you got it right. So now let's go to the last example, example 4. 3, 5, 4, 6. Well, they're about the same size, so you can choose either pair. The only issue right now is everything is positive, which means when we actually try to multiply them, we need to multiply one of them to multiply with a negative number, so it actually can create an opposite. So I'm still going to use, well, since the previous one I used the 3 and the 5, for this time I'm going to use the 4 and the 6. 4 and 6, they can both go into 12. You can also choose to use 24, either way works. So for the first one, I'm just going to do it normally, multiply it by 3. So we got a 9x plus 12y, which equals to 42. But now when we try to multiply the second equation, because we're focusing on these two, I already have a positive 12y, so I actually need a negative 12y in corresponding, so that they're opposites, so that they can actually eliminate with each other. So I need to multiply the second equation by a negative 2, not just a 2, because multiply by a 2 is still going to be a 12y. They won't be opposites. So I need to multiply with a negative 2. That's going to give me a negative 10x minus 12y, which equals to negative 40. There you go. These two, 12y and negative 12y, that's a 0. 9x and a negative 10x, that's a negative x. On the right side, 42 minus 40 is a 2. Divide both sides by a negative 1. Because the 0, we can ignore it. Divide both sides by a negative 1, so x equals negative 2. Now I can just plug back into any equation to solve. So there you go. 3 times negative 2. I replace the x with negative 2 because right now I know x is negative 2. Plus 4y equals 14. So negative 6 plus 4y equals 14. Add both sides with a 6. 4y equals 20, so y equals 5. That means I got negative 2 and 5. Now I can actually check. Since I used the first equation to solve, I'm going to plug this answer into the second equation. So 5 times negative 2 is 6 times 5. Since x is negative 2, y is 5, I just replace the x and the y. 5 times negative 2 is a negative 10. 6 plus 5 is a 30. Add together, that is a 20. That means we have solved it right. And that is example 4, which is the last example for this lesson. Thank you.